Hi, I'm Bob. Let's solve the problems for the third section of Chapter 8 about the competition in the short run. Like other firms, a competitive firm follows a two-step process to decide its output level and whether to operate or shut down. First, it determines the output at which it maximizes its profit or minimizes its loss. Second, it decides whether to produce or to shut down at that output level. We have already seen that any firm maximizes its profit at the output where its marginal revenue equals its marginal cost. A competitive firm's marginal revenue equals the market price, which makes the analysis easier. We will answer the first 9 questions in this section today. Let's solve exercise 3.1. A marginal cost curve may be U-shaped. As a result, the marginal cost curve may hit the firm's demand curve or price line at 2 output levels, which is the profit maximizing output, Y. The profit maximizing amount of output satisfies the second-order condition for a local maximum. The second derivative of profit with respect to output is negative. It means the change in the marginal profit is negative at that output level. We can write out the profit as 3 terms, where the revenue equals the market price times the quantity for a competitive firm. The second derivative of profit with respect to output equals minus dMc over dQ. At the profit maximizing output Q star, this second derivative is negative, which means the slope of the marginal cost curve is positive at Q star. In other words, the marginal cost curve is upward sloping at Q star. It corresponds to point E2. Let's do exercise 3.2. The cost function for Acme Laundry is as follows, where Q is tons of laundry cleaned. What Q should the firm choose to maximize its profit if the market price is P? How much does it produce if P equals 50? A profit maximizing firm sets its output where marginal revenue equals marginal cost at that output. A competitive firm is a price taker and faces a horizontal demand curve. Its marginal revenue equals the market price. So, the competitive firm maximizes its profit by producing the output at which its marginal cost equals the market price. For the cost function in this exercise, the marginal cost is 10 plus 2 times Q. At the profit maximizing output Q star, the marginal cost equals the market price P. We obtain Q star as a function of the market price P. If the market price is 50, then the profit maximizing output is 20. Let's find answers to exercise 3.3. If the cost function for John's shoe repair is as follows, what is the firm's marginal cost function? What is its profit maximizing condition if the market price is P? What is its supply curve? The marginal cost function is 10 minus 2 times Q plus Q squared. A competitive firm maximizes its profit by producing output Q star where marginal cost equals market price at this quantity. A competitive firm's short-run supply curve is its marginal cost curve above its minimum average variable cost. We derive the firm's average variable cost function and then draw the supply curve for the firm. We find the minimum average variable cost by equating the marginal cost and the average variable cost functions, because the marginal cost curve cuts the average variable cost curve at its minimum. So the firm's short-run supply curve is its marginal cost curve above the price of 9.25. We draw the curves in Stata. You can find Stata's graphic commands in the description below. Let's go to exercise 3.4. The government imposes a specific tax of 2 on laundry. Acme Laundry's pre-tax cost function is as follows. How much should the firm produce to maximize its after-tax profit if the market price is P? How much does it produce if P equals 50? The after-tax cost function is 10 plus 12 times Q plus Q squared. A competitive firm maximizes its profit by producing an output level where marginal cost equals market price. We obtain the profit maximizing output as a function of market price P. If the market price is 50, the output equals 19. Let's solve exercise 3.5. If the pre-tax cost function for John's shoe repair is as follows, and it faces a specific tax of 10, what is its profit maximizing condition if the market price is P? Can you solve for a single profit maximizing Q in terms of P? The after-tax cost function is as follows. A competitive firm maximizes its profit by producing an output Q star, where marginal cost equals market price at Q star. We can solve for Q star. It is a quadratic equation. Using the quadratic formula, we can solve for Q star. There are two possible solutions. From exercise 3.1, we know that the slope of the marginal cost curve at Q star must be positive to ensure profit maximization. The slope of the marginal cost curve is dmc over dq. Q must be greater than 1 for a profit maximum. We find that only one of the two possible solutions is greater than 1. So only a single output is the solution to the problem. Let's do exercise 3.6. If only one competitive firm receives a specific subsidy of S, how should that firm change its output level to maximize its profit? And how does its maximum profit change? Use a graph to illustrate your answer. Before subsidy, the firm maximizes its profit at E1, where its marginal cost curve crosses the market price line. After receiving the subsidy of S, the firm's marginal cost curve and average cost curve shift downward by S. The firm maximizes its profit at E2, where its new marginal cost curve crosses the market price line. the profit maximizing output rises from Q1 to Q2. The maximum profit increases from the blue area to the sum of the blue and red areas. Let's go to exercise 3.7. What is the effect of an ever lowering tax of new on a competitive firm's profit maximizing output, given that the market price is unaffected? For each dollar the firm earns, the share of 1 minus new goes to the firm. So the firm's revenue is 1 minus new times P times Q. The firm's after-tax profit function is as follows. The first-order condition for profit maximum is the first derivative of pi with respect to Q equals 0. It gives 1 minus new times market price equals the firm's marginal cost at the profit maximizing output Q star. From this equation, we can solve for Q star in terms of the ever lowering tax rate new and market price P. To find out how the output changes with new, we can differentiate the equation with respect to new. The change in Q star in response to the change in the tax rate new equals minus P divided by partial marginal cost over partial Q star. From exercise 3.1, we know that at profit maximizing output Q star, the slope of the marginal cost curve is positive. Thus, the change in Q star in response to the change in new is negative. The competitive firm's profit maximizing output decreases as the tax rate increases. We can also see it in the graph. The effective market price drops after the tax, which shifts the market price line downward. The profit maximizing output falls from Q1 to Q2. Let's find answers to exercise 3.8. According to the application, fracking and shutdowns, conventional oil wells have lower shutdown points than those that use fracking. Use figures to compare the supply curves of firms with conventional wells and those that use fracking. The shutdown point is the minimum of the average variable cost curve. Fracking oil wells have a higher shutdown point at P2, while conventional oil wells have a lower shutdown point at P1. The competitive firm's short-run supply curve is its marginal cost curve above its minimum average variable cost, the blue part of the marginal cost curve. Conventional wells start supplying oil at a lower market price than new wells using fracking. Let's solve exercise 3.9. In the summer of 2012, due to plentiful lobsters, the price of lobster in Maine fell to $1.25 a pound, which was 70% below normal and nearly a 30-year low. According to Bill Adler, head of the Massachusetts Lobstermen's Association, anything under $4 a pound, lobstermen can't make any money. At least 30 boats announced that they would stay in port until the price rose. However, Canadian and other U.S. fishers continued to harvest lobsters. Why did some lobster boats stop fishing while others continued? They have different shutdown points. The competitive firm shuts down in the short run only if the market price is less than the minimum of its average variable cost. The lobstermen stopped fishing and shut down because they had a higher average variable cost curve, and the market price was lower than the minimum of the average variable cost. Other lobstermen did not shut down because they had a lower average variable cost curve, and the market price was still higher than the minimum of the average variable cost. Thank you so much for solving all the exercises with me today. See you tomorrow for the remaining questions in this section. Goodbye. Thank you for watching this video and subscribing to my YouTube channel. See you next time.